Hello friends and welcome to Shri Tech Education YouTube video channel. In today's lecture we will study basics of vibration. Vibration is a vast topic in which or vast area in which various things are included, from which we will study one by one through each video lecture. In today's lecture we will study some basics of vibration. Let us start. Now, what is a vibration? Now, it is defined as an oscillatory motion of bodies in response to disturbance. Now, if suppose any object is there, if it is disturbed by some external force and then it is removed the force, then there will be some oscillations of that body, and that is called as a vibration. Now, a vibratory system involves the transfer of potential energy to kinetic energy and vice versa in alternating fashion. Now, when elastic bodies such as a spring, beam, or any shaft are displaced from equilibrium position, now in this animation you are observing that one spring and mass is there, it is displaced from its mean position or equilibrium position, then it is oscillating about its mean position. Now, if these are displaced from equilibrium position by application of external forces and then release, they execute a vibratory motion. That motion is called as a vibratory motion. Now, this is due to the reason that when a body is displaced, the internal forces in the form of elastic or strain energy are present in the body. At release, these forces brings the body to its original position. When the body reaches equilibrium position, the whole of the elastic or strain energy is converted into kinetic energy. Potential energy is converted into kinetic energy, due to which the body continues to move in the opposite direction. This whole of the kinetic energy is again converted into potential energy, due to which the body again returns to equilibrium position. In this way, the vibratory motion is repeated independently. Now, this vibratory motion has some advantages as well as some disadvantages. Now, this vibratory motion is everywhere, in vehicles, in machineries, in human body, as well as in some musical instruments, as well as not some, in all musical instruments. Because of these vibrations only, these musical waves are created. Now, these excessive vibrations can have some bad effects as well, such as noise will be created, loosening of fasteners, tool chatter, fatigue failure, and discomfort. N number of such disadvantages or discomforts are there due to this vibration. Now, there are some useful vibrations as well. Now, in compression machine, these vibrations will be useful. Now, in stone breaker, there one human has I have shown that is breaking the stone with the help of stone breaker with the help of vibration only. Now, ultrasonic cleaning is there. With the help of this vibration only cleaning, we are utilizing it for cleaning purpose. Now, harmful vibrations will create a noise, wear, fatigue. Due to that, your whole assembly or system will destruct or fail. These are some disadvantages of vibration as well. Now, to start with, we have to see some terms used in vibratory motion, and these terms are very important. In further subsequent lecture, we are going to use these terms. That's why you should know the definitions of these terms. First one, period of vibration or time period. It is the time interval after which the motion is repeated itself. The period of vibration is usually expressed in seconds. It is the time after which the motion is repeated itself is called as a time period. Cycle, second is cycle. It is the motion completed during one time period. Third, frequency. It is the number of cycle described in 1 second. Number of cycles described in 1 second. SI unit of that frequency is hertz, which is represented by capital H suffix Z. Now, which is equal to 1 cycle per second. 1 hertz is equal to 1 cycle per second, and frequency is number of cycles described in 1 second. Amplitude of motion. Now the maximum displacement of vibratory body or vibrating body from its mean position is called as amplitude of motion. Maximum displacement of a vibrating body from its mean position is called as amplitude of motion. Next is natural frequency. Previously we have studied the definition of frequency. It is nothing but number of cycles described in 1 second. Now here is natural frequency. When no external force acts on the body after giving an initial displacement, then the body is said to be under free vibration or natural vibration. And the frequency of the free vibration is called as a free or natural frequency. What is natural frequency? Frequency of free vibration is called as a natural frequency, isn't it? Now next is resonance. When the frequency of external force is equal to natural frequency of system. What is natural frequency? When just force is given and it is released, then whatever vibration of the body is called as a free vibration, and the frequency of that free vibration is nothing but of natural frequency. If this natural frequency matches with some external force, continuously applied external force, then the system starts vibrating with the highest amplitude. This condition is called as a resonance. At that time resonance occurs and the system vibrates with the highest amplitude, and ultimately the system may fail at the resonance. So we have to avoid this resonance condition. To avoid resonance condition, we must know what is the natural frequency of system, because if the external forcing frequency comes more than natural frequency, then there will be breakdown of your system. That's why you should know what is the natural frequency of your system to avoid this resonance. Next is damping. Now damping is resistance to motion of vibrating body. Resistance to the vibration motion of vibrating body. Now what are different types of damping? What is the effect of this damping in the vibrating body? That we will study in further lectures, as well as in this lecture we will just only study what is the definition of damping. Damping is nothing but a resistance to the vibration. Next, degrees of freedom. The number of degrees of freedom for a system is the number of kinematically independent variables necessary to completely describe the motion of every particle in the system. Number of independent variable necessary to completely describe the motion of system is nothing but a degrees of freedom. Now in vibration it is most important to know what is the degree of freedom of that system, so that we can derive one equation based on these degrees of freedom, and we can solve to find the displacement, velocity or acceleration, that is the amplitude terms of vibration. Now there may be a single degree of freedom system, 2 degree of freedom systems, or 3 degree of freedom systems are there in the environment that are occurring. Now first we will see the single degree of freedom system. Examples of these two are shown here in first two diagrams, B and C diagrams, in which one spring, one mass is there. In C diagram, one disc is attached to one shaft. Now there in B diagram, spring mass system, that mass has been displaced with distance x, and that x is the only degree to define the motion of the system. That's why it is a single degree of freedom system. In torsional system, one disc is attached to one shaft. If disc is rotated in any direction by angle theta, then it will vibrate along that vertical axis by angle theta, clockwise, anti-clockwise, clockwise, anti-clockwise, like that, with a single degree of freedom. Now in next example of 2 degrees of freedom system, there I have shown two springs and two masses, m1 and m2 mass. Now if m1 mass is displaced by x1 distance, m2 mass is displaced by x2 distance, then the system vibrate with 2 degrees of freedom. That's why this system is having 2 degrees of freedom. In B diagram as well as the torsional system, 2 rotors are at that shaft in 2 sides, and these 2 rotors are twisted, one is clockwise, another on anti-clockwise direction by angle theta 1 and theta 2. Therefore, to describe that system, 2 angular displacements are required, theta 1 and theta 2. The equation of motion will be based on these theta 1 and theta 2 for this system. In 3 degrees of freedom system, A and B and C diagrams. In A diagram, 3 masses and 4 springs are there. These 3 masses are displaced with different displacement, x1, x2 and x3. In B diagram, a compound pendulum is there in which m1, m2, m3 masses are displaced with different angular displacement, theta 1, theta 2 and theta 3. In C diagram, 3 rotors are there attached to single shaft, and they are rotated again with angle theta 1, theta 2 and theta 3. In all these 3 examples, the displacement, that may be linear or angular, or system displacement, depends on these 3 parameters. That's why it is a 3 degree of freedom system. Such n number of degree freedom system are there that you have to consider. That means, what is degree of freedom? The number of variables or independent variables necessary to completely describe the motion of every particle in the system is called as the degrees of freedom. Now I think you understand that. Next, now vibration parameters. All the mechanical systems can be modified by containing 3 basic components: spring, damper and mass. Now here in this diagram I have shown a human being is there, and in front of him spring is there, one damper is there, and one mass is there. Now what we are studying, vibration parameters. Now these vibrations generally can be explained in these 3 parameters. Which parameters? Displacement, velocity and acceleration. Based on these 3 components only, that is spring, damper and mass. When these components are subjected to constant force, they react with a constant displacement, velocity and acceleration. For example, in first diagram observe that human, if apply some force on that spring will displace by some distance d. Therefore, I have written one equation below that, F is equal to k into d. What I have got due to that spring? Displacement. Secondly, one damper is there. If I apply some force on that damper, there will be some velocity of that damper in that damper. Therefore, I can get one equation, F is equal to C into V, where F is applied force, V is velocity with which I have applied that, and C is damping coefficient. If I am having one mass, and if I displace it with some acceleration a, then if I apply some force there, I will get an acceleration. Therefore, I can write that equation, F is equal to mass into acceleration. Therefore, when these components are subjected to constant force, then they react with a constant displacement, velocity and acceleration. I have to measure in vibration these 3 parameters only, that is displacement, velocity and acceleration. These things you have to calculate in the vibration. The complicated vibratory motion equations will be there, and from that you are getting the vibration amplitude in these 3 terms, that is displacement, velocity and acceleration. Therefore, these are the basic vibration parameters you should know. Next, types of vibratory motion. There are different types of vibratory motion. From that, few types we will study one by one. First is free and forced vibration. Free and forced vibration. What is free vibration? When no external force acts on a body, after giving an initial displacement, then the body is said to be under free or natural vibration. Initial disturbance is given to body and system is left to vibrate without influence of external forces. The frequency of free vibration is called as this natural frequency. This also we have previously studied. The frequency of free vibration is called as a natural frequency. What is free vibration? When initial displacement or disturbance is given to system and system is now left to vibrate without influence of external force, then this type of vibration is called as a free vibration, and the frequency of this free vibration is called as natural frequency. What is forced vibration? When the vibrating system is simultaneously or stimulated by external forces, then this type of vibration is called as a forced vibration. When the body vibrates under the influence of external force, then the body is said to be under forced vibration. The external forces applied to body is a periodic disturbing force created by unbalance in many times. Remember, the external force applied to body may be a periodic disturbing force created by unbalance. Many times it is due to unbalance only. Now, if the excitation frequency matches with natural frequency, there will be resonance occurring in the system. During this forced vibration only, resonance occurs. Due to external forcing frequency matches with natural frequency, there will be resonance. Remember this. This is regarding free and forced vibration. This we are going to study in detail what is free vibration, types of free vibrations once again. But this is basic free and forced vibration. Second, undamped and damped vibration. So what is undamped vibration? When no dissipation of energy is there, this type of vibration is called undamped vibration. No dissipation of energy. What is damping? We have studied previously. Damping is resistance to vibration. That means no resistance to vibration is there due to dampers. At that time, this vibration is called as undamped vibration. That is, no resistance means no dissipation of energy. Now, system without dampers creates undamped vibrations. In many cases, the damping is negligible or very small. For steel, it is 1 to 1.5% only. In many cases, it is very small in case of undamped vibration. What is damped vibration? When there is a reduction in amplitude of vibration over every cycle, the motion is said to be damped vibration. Dissipation of energy occurs there. That is, resistance to vibration occurs there. That is, reduction in amplitude occurs there. This type of vibration is called as a damped vibration. Vibration amplitude decays. The system with the dampers creates the damped vibration. Remember, the system with damper creates damped vibration. Understand what is undamped vibration and what is damped vibration. No dissipation of energy, and here dissipation of energy occurs in case of damped vibration. Next, deterministic and random vibration. Deterministic vibration, it can be described by implicit mathematical functions as a function of time. These are deterministic. That means we can find the magnitude of these vibrations. But in case of random vibrations, they cannot be predicted. The process can be described by statistical means, that is statistical analysis. In case of deterministic vibration, vibration amplitudes can be determined, can be found easily. But in case of random vibration, the amplitudes of that vibration we have to find by statistical analysis. This kind of analysis is very difficult than that deterministic vibration. Now, example of that random vibration is earthquake. In that we cannot find exactly what is the magnitudes of these vibrations because it is randomly changing. That's why they are random vibrations. Understand, deterministic and random vibrations. Now next, types of free vibration. We have seen what is free vibration. When there is no external force acts on a body after giving an initial displacement, then the body is said to be under free or natural vibrations. Now, types of these free vibrations are basically longitudinal vibration, transverse vibration, and torsional vibration. We will see it one by one. First is longitudinal vibration. When the particles of shaft or disc moves parallel to the axis of shaft as shown in figure, then the vibrations are known as a longitudinal vibration. See in that diagram, if suppose one shaft and one disc is attached to that shaft at one end and at one end it is fixed, then consider the B is the position, initial equilibrium position of that disc. If we displace that disc at point from B point to C point and then release, then the vibration parallel to the axis of shaft are known as a longitudinal vibration. In this case, the shaft is elongated and shortened alternatively, and thus the tensile and compressive stresses are introduced alternately in the shaft. In this case, the shaft is elongated and compressed alternately. Therefore, tensile and compressive stresses are induced in the shaft alternately. Again, another example I can quote here as vibrations in the spring along with the mass. That is nothing but vibration in the spring along its length or parallel to its length is called as a longitudinal vibration. Second is transverse vibration. When the particles of shaft or disc moves approximately perpendicular to the axis of shaft. Previously what I have told you, parallel to the axis of shaft vibrations are longitudinal, perpendicular to axis of shaft vibrations are transverse vibration. For example, consider one shaft and one disc attached to that shaft, and that disc has moved from B position to A position, that is perpendicular to shaft, approximately perpendicular to shaft, and then release, then it will oscillate from A to B, B to C again, C to B, B to A again. That means this type of vibration is called as a transverse vibration. Now in this case, the shaft is straight and bent alternately, and bending stresses are induced in this shaft. Remember, for the gate purpose as well as for your exam purpose, during transverse vibration, alternate bending stresses are induced in shaft, whereas in case of longitudinal vibration, compressive and tensile stresses are alternately induced in the shaft. Example, vibrations in the strings of guitar. If you are using any instrument, musical instrument, then you can hear that in case of guitar, perpendicular to length of that strings, you are vibrating these strings so that the vibrations will be transverse vibration. Now vibrations in the cantilever beam can also be the transverse vibration if you vibrate that cantilever perpendicular to its length. Third, torsional vibration. When the particles of shaft or disc moves in a circle about the axis of shaft, then this type of vibration is known as torsional vibration. See in that figure, there is one shaft and one disc attached to its one end, and that disc at initial position is at a B suppose, and it is twisted towards A and release. Then there will be motion of the particles of shaft or disc in the circular manner about the axis. That is, it will twist and untwist about the axis of shaft. Then this type of vibration is called as a torsional vibration. In this case, the shaft is twisted and untwisted alternately, and the torsional shear stresses are induced in this shaft. Remember, here in torsional vibration, torsional shear stresses are induced in the shaft. Example, alternate twisting and untwisting of the shaft, like in this example, in this diagram. Two rotor system in which I can rotate one rotor clockwise, another anti-clockwise and release. Then this twisting untwisting will create torsional vibration. Next, now this much only for today's lecture. What we have studied in today's lecture, we have studied some basics of vibration, basic terms in the vibration. Then we have studied what are the different types of vibrations: free forced, undamped, damped, deterministic and random vibrations. Three main types of free vibrations, that is longitudinal, transverse and torsional. Now next further videos will be based on these three important types of free vibration, that is longitudinal, transverse and torsional. We will find out the natural frequency of these all vibration types, longitudinal, transverse and torsional. We will solve some problems based on that also in next further videos. So subscribe the channel and like the videos. Thanks for watching.